Good morning, this is your Stat Sensei, Mr. Spensei, and this is going to be an exit ticket on the paired T, and the scenario is reaction time that we use in the warm-up. It says, so write the conclusion for the hypothesis test that you conducted in the warm-up. So we need to probably go back and look at our warm-up. So our warm-up, we had this scenario here. Professor Annie Neal measured the time in seconds required to catch a following meter stick for 12 randomly selected students. There's our sample size of 12 and a not randomly selected students, dominant hand and non-dominant. Professor Neal claims the reaction time in an individual's dominant hand is less than the reaction time in their non-dominant. Professor Neal has 220 students, which is our population size, and the differences are normally distributed, which is important because that's our condition 3 for normality. So we're supposed to write our conclusion. Well, we entered all this data into L1 and L2. Oops. So we entered all this data in L1 and L2, and then we went up to the top of L3 and went blue 1 minus blue 2 because it was a paired test, and we were looking for the differences, which we calculated. All right. So we got all this information and we made a decision. And our decision when we just ran it was our decision was to reject the null. So how do we write our conclusion? Well, we start off simply by starting with our p-value, which is right here, is less than zero point 0, less than our alpha 0.005 or 0.050. So our p-value of 0.090, which is less than our alpha. All right. So you can see the part that I just highlighted in yellow matches. The next thing, we reject the null. Well, guess what? That was the next thing we actually said right here. We said we reject the null. So this comes from right here. There is plenty of evidence. We have enough evidence to suggest that the true population mean of the differences, this is a key phrase. Because it's a paired, you must say mean of the differences. Super, super important. I would star that. Anytime you're working with paired, it's mean of the differences. And what do we care about? In reaction time of hand dominance or dominant minus non-dominant, and this might make you feel better about it to write dominant minus non-dominant is less than 0, and this shouldn't be milligrams. This should be less than 0 seconds. All right, is less than 0. So we rejected that, and where that came from, the less than 0, this right here came from my alternative, which is less than 0. And I'm assuming that they measured it in seconds. All right. They obviously didn't measure it in milligrams. So next, write the conclusion for the confidence interval you created in the warm-up. So we talked about where we got the data. It said create a 97% confidence interval. And when we did that, when we ran it, our interval was negative 0.025 to 0.0014. So there's our interval. And so when we go to write it, what was our confidence level? 97% confident. The true population mean of the differences. Once again, if you're working with a paired, this is super important that you have that. All right. In reaction time, and this is of hand dominance, but I think you'd be much better to go dominant minus non-dominant. Always give the order that you subtracted. Lies within the interval blank. Then ultimately we need to come back and explain the meaning. In repeated sampling, we expect this method to capture the true population mean of the differences. Once again, I keep telling you, I keep saying this, mean of the differences, super important. Star it. Make sure you know that. All right. In reaction time of hand dominance, and again, I would always go the order that I subtracted. Dominant minus non-dominant. All right. Appreciate you watching. Hope this helped and look forward to seeing you on the next one. Thank you.